Good morning. Today we're going to be talking about Chapter 3, Section 7, the chain rule. So we know how to find derivatives of the product of two functions, the quotient of two functions, and two functions summed together. But how do we find the derivative of composite functions? Reminder, given two functions f and g, the composite function f circ g is defined by f circ g of x is equal to f of g of x. So how do we find the derivative of a composite function? And the answer lies in the chain rule. So you can kind of think of the chain rule as undoing the composite function. So suppose y equals f of g of x, and that it's differentiable at a point x. Then d dx of f of g of x is equal to f prime of g of x times g prime of x. So we have the derivative of our outside function times with our inside function times the derivative of our inside function. So let's see how this works with a couple examples. I want you to first determine the inner function and the outer function, and then compute the derivative. So for this one, I'll go ahead and walk you through it. The inner function is going to be 5x plus 4, and the outer function is going to be raising something to the power of 3 over 2. So our outer function is raising something to 3 over 2, and the inner function is 5x plus 4. Our derivative is then 3 halves time with our inner function remaining the same to the power of 3 halves minus 1 times the derivative of our inner function. How does that work? Oh, I messed up here. It should be 15. Oh, no, I didn't. We'll have 5 from d dx of our inner function times 3 over 2, which gives us 15 over 2. Replace our inner function with 5x plus 4, and 3 halves minus 1 is 1 half. So now that you know the name of the game, let's see if you can't do it yourself. Here I want you to do the exact same thing, and this time with y equals sine cubed of x. So go ahead and pause and see how far you can get. Here our outer function is cubing something, and our inner function is sine of x. This makes the derivative 3 with our inner function squared times d dx of our inner function. We know that d dx of sine is just cosine, and we can replace our inner with just sine. So we have 3 sine squared x cosine x. Now here's something that's a little bit different. I want you to work on y equals sine of x cubed. And in this case, the cubed applies to the x and not to the sine function. So go ahead and see if you can't determine the inner function and the outer function, and then compute the derivative. So in this case, our outer function is sine, and the inner function is x cubed. This makes our derivative equal to dy dx equals cosine of our inner function times d dx of our inner function. We replace our inner function, take the appropriate derivatives, and we're left with cosine of x cubed times 3x squared. And that's it for the chain rule.